Welcome to Guide Guru. We hope this video helps.
You start by confirming prerequisites and taking immediate action. First, inspect the mast and rod for corrosion, replacing parts that show significant degradation. Next, test soil resistivity. If it exceeds safe limits, plan chemical or mechanical treatment. Once done, de-energize nearby circuits and don personal protective equipment, gloves, goggles, and insulated tools to reduce risk. Make sure to have a continuity tester and clamp meter ready so you can verify connections as you proceed. You now route and secure the lightning conductor. Start by choosing the shortest unobstructed path from air terminal to ground, limiting bends to 3 or fewer to minimize impedance. Use a continuous copper conductor no smaller than 8 mm diameter or equivalent, secure with corrosion-resistant clamps every 5 to 2 meters for mechanical stability and electrical continuity. Once in place, bond any roof fittings, gutters, and service entries to the conductor so all metalwork shares the same reference, preventing side flashes. You finish by establishing a low-resistance earth and verifying the system. Drive the ground rod to the required depth until you achieve under 10 ohms. If not, add 1 to 3 rods spaced properly and interconnect them. Then measure continuity from the air terminal to the ground rod. You should see less than 0.5 ohms. Make sure to document all readings and connections and retest after 24 to 72 hours or following any major storm. Troubleshooting tip: if resistance stays high, treat soil around the rod with conductive backfill.
Thanks for watching. Consider subscribing if we helped you today.